Hi there everyone, welcome to our YouTube channel. Today in this video, we will learn about web and HTTP. So now in this video we discuss about HTTP protocol. Because of this protocol, the first web application is developed by Sir Tim Berners-Lee in 1994, which is www, World Wide Web. Web operates on demand. That means the users can receive what they want, when they want it. So for example, anytime you can search anything on Google. Web page. Whenever we try to access web page from a web page consists of objects. That means every content of our web page is an object. Normally web page consists of HTML file, images, Java applets, audio file etc. Consider a web page having one base HTML page and 6 images. So total 7 objects is present in that web page. Here 6 images are referenced objects. Each object is addressable by a URL that is Universal Resource Locator. Consider the example www.informatsy.info.com/notes. Here www.informatsy.info.com refers the host name, and notes address is the path name of the file stored in the server. HTTP overview. HTTP, which stands for Hypertext Transfer Protocol. It is a web application layer protocol. This web works on client-server model. So as we already discussed about this on our Part 1 video. As this model consists two process, client process and server process. Whenever a client wants a web page, they send HTTP request to server. Then after processing the request, the server sends HTTP response to the client. So this HTTP protocol works on the application layer. In the lower layers it uses TCP protocol. As we know, TCP requires a handshake procedure. So first of all, client initiate the TCP connection by creating a socket at port 80. So once the client initiates the TCP connection, server accepts the TCP connection from the client. Then after the establishment of connection between client and server, messages will be exchanged. Once the data is exchanged, TCP connection is closed. One important thing is HTTP protocol is a stateless protocol. Because each request is executed independently, without any knowledge of the previous requests. HTTP connections. There are two types of HTTP connections. First one is non-persistent HTTP connection and second one is persistent HTTP connection. In non-persistent HTTP connection we will send only one object over a single TCP connection. Once after the exchange of data, TCP connection is closed. Downloading multiple objects requires multiple TCP connections. For example, if you request 6 objects from server, then 6 TCP connections is required. Next is persistent HTTP connection. Here multiple objects is sent over a single TCP connection between client and server. Unlike non-persistent HTTP, here the connection is left open after exchanging the objects. HTTP with non-persistent connections. So now we will study how exactly HTTP works with non-persistent and persistent HTTP connections. Let's suppose user enters URL http://www.some/school.edu/some department/home.index. Consider in this case it as one base HTML page and 10 images. So observe the process here. First HTTP client initiates TCP connection to HTTP server over port 80 with this URL. Then next HTTP server at host address is waiting for TCP connection at port 80. Then it accepts the request and notify the client. So now the TCP connection is established between the client and the server. HTTP client sends HTTP request message into TCP connection socket. Here the message indicates the object that client need referred by the path name. Next, HTTP server receives request message. Then forms the response message containing the requested object and sends into its socket. Once the response message is sent to the client, HTTP server closes the TCP connection. Then HTTP client receives response message containing HTML file, display HTML with 10 referenced image objects. So as this is non-persistent, the following steps is repeated for rest of the 10 objects. So this is how HTTP works with non-persistent HTTP connection. Non-persistent connection, response time. So now we have to study the efficiency of this non-persistent HTTP connection. So we consider its response time. One parameter we use to calculate response time is RTT, which stands for round trip time. It is the time required for a small packet to travel from client to server and back. Have a look at the diagram. We require 1 RTT for establishing the TCP connection between client and server before requesting the file. And then it takes 1 more RTT to request and receive file from server along with some file transmission time. Here we define the time taken by files to reach client. Larger the file size, greater the file transmission time. So the total response time for non-persistent HTTP response is 2 RTT plus file transmission time. But to receive 10 more objects, the response time is 10 times more along with this. So this is how we calculate the response time for non-persistent HTTP connection. Now you came to know, it takes 2 RTT per object, so this is one kind of disadvantage. If it takes 2 RTT, OS will be overheaded for creating NTCP connections. So to overcome this we have persistent HTTP. Persistent HTTP. In this we exchange subsequent objects over a single TCP connection. So server leaves connection open after sending response. Hence, subsequent HTTP messages between same client server sent over open connection. The server closes the connection only when the connection is not used for a certain amount of time. So by default mode HTTP uses persistent connections with pipelining. Since this method requires only 1 RTT for all the referenced objects, the performance is improved by 20%. So that's all for this video. In the next video we will continue this topic. Until then please like, share, comment and subscribe. Thank you.